and we'll just translate that. It's gonna be easier sometimes if you're just like, screw it, and I just need to make a character, make him go left, and you're just like, all right, left, left. I understand that. So. Left. DD right. Makes me think of King DDD. DDD. What the hell are our axes? I think X is forward and back. I think Y is. Is Y up and down? Or is it Z that's up and down? Ah, let's just guess. Let's just say Y. And we'll come back and fix it later. So it looks like that's all of our basic controls. So let's just throw comments on everything, because comments. So let's see, we don't need this getter up there, we want it below. Call to update with no locomotion. Call to update physics locomotion. Call to update as if we're flying. Call to update as if we're a character with legs. Call to set the position. Maybe set position should actually like return a boolean if it was successful. Nah. Let's not get complicated. Okay, let's throw all the position stuff together. Let's organize this a little bit better. Position with position, velocity with velocity, that whole thing. Let's throw jump a little bit up there so we can find it next time, because we need to implement jump. Center along location. We don't need that right there, do we? Our velocity internally. Alright, so these internal sets we're going to throw up top because the public ones are really pretty stupid and we're not going to be touching those very often. So we'll just throw them there. This is what state we are in while moving. While existing, I should say. This is how we move. This is a helper for basic directions. Because computers don't know left from right. They don't know anything unless you tell them. So let's see, we got that going on. Let's just do our update real quick. There's not too many movement types, so I'm not going to complicate the update logic any more than just a switch. Because we don't have 200 million different movement types in this game. We should just have, you know, stuff that flies, stuff that doesn't do anything except get set absolutely, and stuff that, you know, kind of runs around. And boulders and the rest, which might be careening down mountains at people. But that's just physics stuff. Let's do flying. Update flying, locomotion. And the actual big one, which is what probably almost everything, which will just be locomotion. Alright, so that is that. So we're gonna need some basic helper methods here for these things, because like when we're gonna need like, can I move over here and all that. But for now, basically what we're gonna do is we're gonna make like a really simple, just like set position based on velocity and position. So let's add that void. We're just gonna call it move object, and we're gonna give it delta t. And this is gonna be the dead simple, like just Patrick this thing over there. So all these things are just gonna call move object for starters. So nothing crazy. So we also want to grab like our previous positions and velocities and set them at the beginning of our update. So vector, let's do position equals get position. F vector velocity equals get velocity. And at the end of this, we're going to set previous position equals position. Previous velocity equals velocity. So that should just kind of work there. So we're moving our object. So in order to move our object, we're just going to do it real simple. We're just going to call it get position. And we're just going to say position equals, let's see, m current velocity times delta t. So it's going to be position equals pos plus delta t. And let's also make our current velocity go towards our wanted velocity. We should also have gravity in here, shouldn't we? So maybe we should have a we'll have a mass effect variable, which will be how much gravity affects us. And let's just start it off with 1. And let's throw a getter and setter for that. So float get mass effect void set mass effect. And that should be pretty simple. Mass effect. Excuse me. Just dying over here slowly. Alright, so we need to get and set the mass effect for this guy. Just throw that at the bottom because now we're going to look at it again. So we're going to need a gravitational constant here. Where should we store a gravitational constant? Maybe a static float here. Oh, what is gravity? It's like 8 point... It's like 8 point something meters per second. 9.81, alright. So we could probably data drive this at some point, but I really don't think we're going to be... I mean, we'll be tweaking it, but we can always move this stuff out into something later. Some level properties that we slap on there for like G physics, and then, you know, we can have one level with moon gravity and one level without. All that. Let's not do everything all at once. Let's just not do that. So we're going to want our wanted velocity. Let's just double check which way is down and all that stuff. So let's just say current velocity. Student current velocity equals current velocity plus delta t times mass effect times our gravity. And we'll just do set velocity on that. Is that what we want? That way it'll clamp all of our crazy town shenanigans with if we're going too fast, it'll stop us. And since we're adding it in here, the downward stuff will still be working. We're just going to call set position with our new position after we've created it. So just a basic move, nothing else. So let's fix all of our errors real quick. Yeah, we changed global utils, recompile everything. Oh yeah. It's a movement type, not a movement state. That's simple. Not convert from. I don't know the right syntax for this, so let's see if it's used anywhere else in this entire project. Oh, it is actually a function. Well, that's simple enough. Could not be initialized. Yeah, not a problem. Let's see. Wanted direction is not a member. That's because we changed it to wanted velocity. Let's just get rid of that. So velocity.normalize. so if the size is less than maximum velocity, then what that means is that we should actually do something. So we should be just setting this to velocity up here, and then saying if this is less, then let's just normalize it and set it. Sounds reasonable to me. So set wanted velocity is direction, wanted velocity normalized. And the reason we're doing this is just to make sure that somebody passes in a non-normalized direction. We're not just going to explode for no frickin' reason. Because if there's one thing you can count on, is that when you write something like this, and you're like, well, they'll never pass it, something like that. It'll happen, and then everybody will rely on it, and then you're screwed. Simple enough. And if you're wondering how I'm compiling, I'm just I re-hotkeyed Control-Shift-B to actually just build the current project and not absolutely everything. Hotkeys are pretty important because scrolling around looking for crap is never fun. Set wanted velocity. Simple enough. Let's just skip that one. Alright, so we got our movement object. Awesome. So that's actually going to be on something. So why don't we actually start using it? You know, because we can like set our velocity and all those things. So if we've got our movement, this is a movement controller object right here, which is checking our virtual controller and then just hard setting our actor transformation based off of that. So what we want to do is we want to change this real quick. This should be in the logic controller, not the biped movement controller component, right? So we'll move that later, but basically we just want to make sure that our velocities and all those things are properly. So what we're going to want to do is, it's like our velocity should be like 2000. Let's see. So let's set our wanted velocity like that, and the question is, how should Bitey move? Like if we got an Xbox controller hooked up, and I think you're just moving left and right, and then when you're in the air, you're gonna be like, you know, doing air control. So let's just do the basics right now, which is left and right. And we're gonna have like an if else say, like if you're in the air, use the axis values for like the left stick. Otherwise, use like the just if the stick is to the left or right, and then move that way. Because I imagine we'll have a button for jumping, because platformers need buttons to jump. Because it's just, you know, if you're using an analog stick to hit up at the correct time, that's just a complete pain in the ass. That's not fun at all. So what we want to do is we want to, this guy, why don't we just make sure that if we copy paste this somewhere else, it'll still work, since this is inside of a movement controller object itself. And it's going to be in a logic controller. We need to actually go fetch our movement itself. So let's look at what we got on our entity actor. Oh, that's the proxy actor. So we need to get the movement controller. So Is this actor actually us? Yeah. Keep looking at all the wrong things. Let's just grab our entity actor. We're gonna throw that up on another window. Just so I can see what's going on. So this is an actual Dashkin entity actor. So if our actor is not null, let's grab our movement object. So let's call it get movement controller. So it's pretty clear we don't want just a movement controller. We're going to be grabbing this a lot, so let's make a shortcut method real quick. So we'll just do that real quick. So just a nice simple shortcut. So what we're going to do is we're going to check if our movement controller is null pointer. We're just going to return a null pointer. Else we're going to return movement controller, because this is a movement controller component, not the movement controller object. We're going to need to go to the movement controller component, and it's going to be get movement object. So that should do that. Let's just double check real quick that this actually returns what the hell we want. That, you know, we've actually got a movement controller object on here. So yeah, right now we're making this guy, and that's what we're returning. Not a problem. Let's go back to our logic. So this is going to be get movement. So if movement is null, let's just bail out of this guy. Otherwise, we're going to want to set our velocities here. So let's just set it to begin with. So F vector, we're going to say this is going to be our direction vector. And we're going to set it to our 0 vector. Oh yes, this is telling me what's up and down. Move object. Yeah, this is totally wrong here. I'm just adding to the vector, which I shouldn't be. I need a gravity vector, and it looks like if we're down is Z is up and down. Let's go to our globals. Let's just do a static F vector. Just do gravity vector. So it's going to be 0, 0, negative 1. So we should be doing is multiplying by both of these guys. The reason I'm doing both right now, like we got gravity vector and gravity, is because we might have something else that's modifying what the effect of gravity is at any time or whatever. I don't know. Bitey in space. We'll make it happen eventually. Alright, so let's see. We want to, this is going to be our direction, so our direction vector dot z, we're going to add, we don't need delta t on this, we're just going to say, we're just going to add 1 to that direction. So if you hit both up and down at the same time, it won't move. So left is, so let's just do a negative. Alright, so the update on our movement object is going to get called, and then it's going to call our update? No, we're going to want this to happen first. So, virtual controller is null, or actor is null, or movement is null. Then we'll break out. Let's just do if else. And throw our update there at the bottom. So what we're going to do is we're going to call movement. We're going to set it. So we're going to call set wanted velocity with the direction with this guy and the wanted velocity of this. So hopefully we should accelerate to this, towards this speed. And did we actually have like a does our set wanted velocity actually do anything? It just sets our wanted velocity. And we've got ourselves falling. Let's turn off gravity on this, because that's going to cause some problems here real quick. So we're just going to set our mass to 0 here. Remote me later. So they're going to wonder, why the hell is the gravity working? You're like, oh yeah, you remember on that one stream you threw that disable gravity at the top of the biped movement controller component? Because the movement controller component was controlling how we were supposed to move when it shouldn't have? Oh yeah, that. So we need an acceleration on our guy, like how quickly is he going to accelerate towards his wanted velocity? So let's go ahead and add that. Let's just set it at maximum. So basically what happens is we're going to move towards our wanted velocity. And how exactly should we move towards the velocity? Do we just add a vector in its direction, multiply by time? Or do we do it by each individual axis? So we are going to have acceleration times delta t times m wanted velocity. Let's just work out a vector. This is going to be our wanted. This is going to be our velocity displacement. So what we're going to do is we're going to take our current velocity, we want to get the difference between each of these things. So we're going to do like f vector difference, and that's going to be our wanted velocity minus our current velocity. And when we just do it per axis, so if velocity how exactly do we want this to work? Let's see, if we're to the left, if our velocity displacement is 1, let's say we're going from 0 to 1, and our velocity displacement in x is, let's just say 1 bajillion, because we need to snap properly to that velocity, and difference in x is 1, and we set to 1. Our velocity displacement in x is negative 1000, difference in x is negative 1, then we set to negative 1. If our velocity displacement in x is 1000, difference in x is negative 1, then we set to negative 1, I guess. Yeah, pretty much. And welcome to the first time I've been streaming with coding, Lucas. I'm still trying to... It's a bit distracting, streaming and all that stuff, just while coding, so kind of moving a little slow, and it's boring, but whatever works, right? Maybe I'll get more comfortable with it. So basically, it's looking like if the absolute value of the velocity displacement in that vector is greater than the difference, then we clamp. Otherwise, we add. Is that a rare joke? These are the rarest of jokes. You'll never find rarer jokes than here. Alright, so if our velocity displacement, we're going to do it by axis here. So velocity displacement x, is it f math maybe? That's what's got absolute value. Yes, it is. It is a tech stream. Welcome, Karakan. Have you guys got any questions about technology or anything else? Go ahead and shoot them out there. Is it just abs? Is that what this is? Is that what I'm looking for? It's just map.abs. Alright, well, is this in something that is specific? Yeah, that's in Android. It's fmath abs. Well, I was looking at that frickin' site to find it. I wasn't finding it easily. But the absolute value of the displacement is greater than the absolute value of the difference, then we're just going to set our wanted velocity.x equals, well, no, current velocity dot x to the ends of time. Otherwise, we are going to set our current velocity dot x is going to be equal to our current velocity dot x plus velocity displacement dot x. So we're going to clamp to all the different axes, because it may be that one of the axes is closer to being correct than the others, and we want to clamp to that instead of doing some weird crap. So let's go ahead and copy paste the hell out of this and cause bugs. What's the meaning of life? Well, depends on what your point of view is, right? Like the meaning of life is just in general, obviously, is to create more life, right? Like that's just reality. That is what living beings do. That's why they exist at the moment. That's the meaning of life, is to continue life. So this is going to be, I'll just segment this off real quick. Move towards our desired velocity. But if you're looking for more philosophical shenanigans, like what else would be the meaning of life, right? Like, I guess a more specific question would not be what is the meaning of life, but what gives life meaning? Perhaps turn it on its head, because that would be, I think, kind of the other side of the coin there. And for me, at least, just having something to do. You know, like having a purpose is all there is. Actually, as naturally as 42. Obviously. I mean, we already know the answer here. Because people go absolutely nuts if they got nothing to do. Like, on the hardest criminals, you know, the most ridiculous, messed up psychos that the human race has produced, nothing is worse than isolation. Yeah, the purpose. What gives life meaning? What is the purpose? It's all just a bunch of chemical imbalances anyway. So we should be able to move our character around now, because we've got our virtual controller. We're setting our direction vector. This looks wrong. Yeah, direction vector, not direction. wanted velocity. Well, that was because what? They had an error in the machine they created. Right, that was kind of the thing, was that they had screwed it up at the beginning or something. I don't know. I didn't read the books. I just watched the movie, which was pretty good. Something something dolphins. Something something. We're not as smart as we all think we are. Forgot how to drink water. That'll happen though. Well, you probably know more than I do about Hitchhiker's Game. So let's see if this guy flies off into space. Guess what's happening? Nothing. Which we can work with that. We can work with nothing. What in the hell? What? I'm moving something here, but it's not the right thing. Alright. So move object's not even getting called, so that's usually one of the first things that happens with debugging your code, is like, is your code even getting called? If it's not getting called. Oh yeah, because I never set the movement types, and movement type's nothing, so that would be why nothing's happening, because we told it to do nothing. Very good. So let's set our movement type. Let's do it at the top here as well. So set movement type. Set our movement type to flying. MT flying. So yeah, since you guys are here, I can go ahead and kind of give you the intro spiel as to what the hell I'm even working on. So I like to make big diagrams because big diagrams are always good. They're helpful for kind of when you've got a whole bunch of stuff to do. It's hard to know where to get started. So the thing is, right now we've got our asset pipeline in order for a lot of things. So like we can get stuff into the game. Like we can get Fat Sack, we can get Bitey, we can get all the animations, and he's got the right physics boxes and all those things. But the world doesn't exist, and we need stuff to be in the world, and we need to be able to move it around. And just having a log in there that doesn't do anything really isn't helpful. So basically, we've got this actor, and Unreal 4 works with actors. So a thing in the game, like a Fat Sack, a tree, something else, is an actor. And so on this actor, we've got a flipbook, which the flipbook is all the pictures. And I'm waiting for this to compile here so I can kind of pop this open, and I can show you what a flipbook looks like. Because for an actor to be visible, it's got to have something that actually you can see. I mean, it seems pretty obvious, like, well, it has to be visible for you to see it, but, I mean, programming is all about just idiotic things. So a flipbook, basically, if we go into, we've got our fat sack here. As you can see, he's got all these different things that he's doing. We can show some of his collision. So we can see him digging away furiously, or falling through the air, or trundling along, or rolling along. So each one of these individual animations here, let's go to the dig one. And this is a flip book right here. Basically, it's a collection of frames. You can see all these different sprites down at the bottom. So that's what our flip book is. We have a whole bunch of flip books on our specific critter. So that's the flip book has all the sprites, and the sprites have all the physics. Yeah. So that's kind of the, flip book is all the graphics. Then we've got our entity data. So on our fat sack himself, we've got to have actual stuff like he's a fat sack. He's he's an actual fat sack thing, and then he's an enemy because fat sacks are the enemy, and what health does he have? And then we can add some custom properties on there, like what controls him, and let's throw the fat sack brain inside of the fat sack body because maybe we got Bitey and we make him act like a fat sack. It's totally possible. And we have his movement stuff and his movement controller and all that basic stuff. So fat sack does fat sack things. That's kind of the entity data, which will get unpacked by the actor so that it knows what to do. Got an animation controller. That's just going to tell the flipbook basically what to play. So when you say, hey, animation controller, play the dying animation, the animation controller can go do that. The logic controller is kind of the brain, and it's pretty complicated. We haven't built it yet, and it's going to basically figure out what needs to be done. The movement controller is what we're working on right now, which is basically going to actually move our thing through the world. And we've also got this, basically, the Dashkin player proxy actor, which it's kind of like Mario 64, the Lakitus following you around. That's actually the player, is the Lakitu. And you're not actually Bitey, right? You're the thing that's watching Bitey. And so we have, that's the thing that captures the input and sends it over to this virtual controller on the actual actor, this actor itself, and that is how we can actually get input over to this thing. So right now we're working on this movement controller, and we have different types of movement. Like there's physics movement, which is just simulated stuff. So that's a boulder rolling down a hill. We got flying movement. So that's going to be something that can just, it's going to be in the air. It's going to be flying around, even if it's touching the ground or something. It's still flying. We've got locomotion movement, which we're going to have. This is a very simplified, but it's just somewhere to start to kind of ground my brain. Locomotion movement are things with legs, things that are moving around, control. So we got like on the ground and in the air. So we got like sliding, stationary, moving, and all these things. And then, well, what does the movement controller do? Well, we can set like the wanted velocity and location. We can jump. There'll be other actions that we want to kind of take. And then what's the output? Well, we can check if we're on the ground. We can get like what ground we're on. We can cast a ray into the world. Like I want to know if something's in front of me. We can override like our animation. So maybe the movement controller controls if we're running or if we're walking, and maybe we want our brain to say like, no, we actually want to override that animation to something else, like we died. It doesn't matter that we're moving, we died, so we should play the death animation. Who cares? And then the movement controller is going to be calling like the physics simulation for raycasts and the animation dictionary to figure out what animations to play. Because right now we haven't actually customized the editor, but like we have just ridiculous amounts of stuff to set for all of our different animations. So like his idle, we have to go through like 20 clicks just to set it properly, which is just a giant pain in the ass. So we'll be working on that. So that's kind of it today, is we're trying to make it so when I press the keyboard, that we crash. Yeah, we set our position to infinity. So obviously we have problems. But yeah, so we'll actually go that side. Flowcharts, that's Visio. That's the expensive Microsoft Office Visio stuff. You can get away with doing tons of different things, but I'm used to making really complex server diagrams for things. So I got used to using Visio. And well, it's not a crash. It's an ensure condition. It's not actually a crash. It was just like, hey, you're trying to set your actor to infinity. Are you sure you want to do that? That's just an assert. So I haven't crashed yet, but give me time. We can make it happen. Actually, yeah, this is the camera position, so we're gonna want both. We're gonna want breakpoint there, and we probably don't need an update camera position thing getting yet. So let's play. All right, so what is our velocity displacement? We're in kind of a debug mode, so we can't actually see what everything is. Since we're running in a development editor, I can't just like mouse over these variables and see what they actually are, because those variables got optimized away. So we're right now just setting our velocities, and it looks like our current velocity got set to 0, so that's good. And then our current velocity got set to 0, so we're going to call set velocity with a 0. And we are setting our velocity to 0, which is great. Our maximum velocity, our current velocity is less than our maximum velocity, so we're setting our velocity to our maximum velocity. Okay, that's obviously wrong. Hey, we're not going at our maximum speed. Let's go at our maximum speed then. That's not what physics is about. We're at rest and we can go the speed of light, so obviously we should just go the speed of light. No wonder it went to infinity. It was at infinity. We told it to go there. If you're wondering what music I'm listening to, I'm just listening to the drum and bass on drum and bass on Twitch's music. So it should be all approved music for stuff. So let's see what's going on now. So what are we setting our velocity to? We're setting it to 0. It's good. We shouldn't be moving. So our position is going to be our delta t plus our position. So our position should be good.